Hello everyone, welcome back to Adrian's Digital Basement. For today's video we're going to be working on the Commodore 64 Diagnostic Test Harness that Sven sent me all the way from Germany. I showed off the PCBs he sent me in mail call number 1, the first of such videos I've made, so if you haven't watched that, click the link in the description below or in the box, whichever corner it is, to see that video. As a side note, I'm shooting this on my brand new Panasonic Lumix G9 camera, I think called the G95 in other international regions, and I'm also shooting with some new lights for my basement, so hopefully this sounds and looks better than it was with my old camera, and of course, hopefully, and I don't know yet because I haven't used this camera much, no more crashing. Let's get right to it. So before we take a look at putting together this kit, let's take a look at why I want to put this kit together. On the bench, you see my good old handy ZIF 64, and I have the Easy Flash 3 cartridge. And on here, I have actually flashed one of the diagnostic ROMs that is commonly used for the 64. Let's just take a look at that. Now, let's pop this in the 64. There we go. Hooked up to the good old 1084 here. I have down under tools. I found this collection online of just a bunch of useful tools for the 64, but C64 Diag Cart B, I'm pretty sure that this is the one that's going to work with it. Diagnostic Rev 586220, and taking a look at Sven's board, Diagnostics Rev 586220, so it matches what's on the computer right now. When the diagnostic runs through, you hear it's doing the beep 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 SID test, but notice here we have a whole bunch of things that say bad. Cassette, control, serial port, user port, interrupts, and these 3 ICs, all marked bad. And the reason for this is the Commodore 64 has no way to actually test its I/O lines unless you use the user port, which is what this is, and you run cables to things like the cassette port, which is this little PCB, or the joystick controller ports, which are these 2 connectors, which run with cables to this, or you have a loopback connected to the keyboard, which will test that, or we create a loopback connection inside the IEC port. This is the connector that would go into the serial port on the back of this. That's where you hook up your disk drives. So let's talk about building this thing. I've laid out everything on the bench, which I think I'm gonna need to build this thing. All the information you need to build this is on Sven's GitHub. I'll put a link in the description to that, so don't forget to check that out. There he has the files for the PCBs themselves, so you can get them made, but also the instruction manual, plus the building materials or BOM for everything we'll need to put this together. And if you don't have an Easy Flash 3 cartridge like this, you'll need a diagnostic cartridge to plug into your Commodore 64. Sven's GitHub has a PCB to make one, which here it is right there, VersaCart 64, but since I already have the diagnostic on this Easy Flash, I don't actually need to put this one together, so we'll skip this one. Oh, I almost forgot. I'm going to need a couple 100 nanofarad bypass capacitors for the user port board. So ignoring the PCBs themselves, I've obtained everything you see here off of AliExpress. Of course, that means being patient and waiting for that stuff to come. This is why I'm putting this kit together now, even though Sven sent me these PCBs months and months ago. When I received these PCBs, they were actually bare, and I've already installed these 2 chip sockets along with the user port connector. But rest assured, I did buy this user port connector and the matching cassette port one off of AliExpress. On Sven's GitHub, you'll see a picture of the entire kit assembled, which kind of gives you an idea of how it should look once it's done. And he has another picture, which I'll show here, actually running the diagnostic that I just showed running on my own Commodore 64, and everything showing okay with nothing bad while he has the harness connected. What's even cooler, and I won't be doing that for my kit because I don't really care that much, is he does provide STL files so you can 3D print cases for all of these parts, which means they'll look extra professional and real as opposed to just bare PCBs, which is how I tend to keep things. Alright, time to warm up the soldering iron and get started assembling this stuff. Okay, I'm going to try some dual camera action here using my old crappy camera and the new camera together. So I'm going to start with the cassette PCB because I want to show you guys how I connected the user port connector. It's exactly the same methodology you use to do this. And these connectors are a little bit different than, say, a standard pin type connector here. Taking a close-up look with the pins, I'm not exactly sure what these originally connected to or how these work. But if you take a PCB, it does fit and line up in between the contacts. But there's a lot of space there, so we're gonna have to do some bending of the pins to make this work. So I did this on the user port board, and all of the pins are soldered on and connected well, and it makes the whole thing quite stable. So when you plug this in and out of the back of the computer, you know, it works and it doesn't just flop around. Now, unlike the originals, which had a little slot cut inside the connector, these aren't keyed in a specific way. So we just need to solder them on any which way, and then when you plug them into the back of the computer, you need to make sure that the traces and the components face up. So I'll move this out of the way because my method of dealing with these is just to bend them. And they're quite springy, so when you bend them, you gotta go quite a bit past, and then they'll spring back. Hopefully you can see this, but when we look at these, they're a lot closer together. So to get the PCB in, it's almost to the point where I actually have to kind of bend these down a little bit with the edge of the PCB. It's a little fiddly, but don't worry, this happens once. There we go. So now this is actually kind of holding itself on. You can see this can go either way. I'm going to try to solder this on where it's at a 90-degree angle. So I usually try to find something to kind of prop up the PCB. And I see one part of my scissor there, that pretty much does the trick. Then we have to make sure that this is totally aligned, like that. So it's correctly straight on every which way, and we'll dab a little bit of solder on the tip here, heat up the pad, and just flood the solder on, like that. I'm just going to do one to start with. So it's not totally straight, it's a little downward slanting. So I'm going to melt that and I'm going to reposition it just so it's straight. Let's solder all of these pins on. All right, so this is looking really good. No issues with that. All right, that's one cassette port board assembled. Okay, let's move on to this little board here for the keyboard port. He does say right here, no pin, so I actually did snip this and I didn't solder it, and I guess theoretically I should shove something in there. That way you don't accidentally put this on backwards. Now all that needs to be done on this is there's an LED and there's a resistor. The resistor that's needed is a 330 ohm. Let me just double check this one. Yeah, 330. So I'll snip this off. And I'm going to put this on the back of the board here. You can put it on either side, whichever works better for you, but because I'm using the connector there, I'm gonna put this way. And then this LED, there we go, like that. Let me just double check and see to make sure the LED negative is going towards the resistor. Okay, I'm glad I checked that's actually backwards. On this cassette port adapter, the negative on the LED is actually going towards the resistor, but on this one, the negative is going towards the ground, which is one of the pins on here. So I'm gonna go and I'm just gonna bend the legs for the resistor over, and let's just get this connected. Okay, it looks good. Let's just snip these legs off. Always keep the little offcuts from these parts because these are perfect as jumpers. If you remember on my PCB that I made for the Tandy, I kind of screwed up and I needed to jumper the 245 out, and if I want to do that permanently, you could just use these little legs to, you know, go from pin to pin. And I think there is a 0 ohm resistor that Sven calls for coming up, and I will be using one of these little offcuts. All right, so these two are done. And now I'll put these away and let's pull over the user port board. So like I mentioned already, I have already soldered on the user port connector, the blue connector here. I put these two IC sockets, nothing really special about that. I have some of the pin header connectors here that will be going on. So there's this one there, there is this one here, and then there is one more right there. So checking the BOM, we have 1 0 ohm resistor. I'm gonna use this metal offcut here. R3 there is a 320 ohm resistor. Well, all I have is a 330 ohm, and he says on the PDF that 330 should work. So I'll stick that in there now. Next we have some other resistors. I'm gonna need to use my multimeter to see what these are. This one here is 150 ohms, and that is in the position R4, which is right next to that 330 ohm. I think this makes a voltage divider to allow something to do with the cassette port drive signal to be used as a logic signal. So I'm just going to solder these two on here because I'm going to have to do something a little bit sketchy for the other 4 resistors that are going on this board. R7 next to the 2 resistors I've already put on. That's the 0 ohm bridge. I'm just going to stick that on right now. Okay, so there are 4 more resistors that are left. R5, 6, and 2, and 1. These need to be 120K. And I just don't have anything in that value. I have 100K and 20K. And what I'm going to do is I'm going to cut the leads off and I'm just going to solder these together and make a little pyramid, so to speak. It's going to be kind of ugly and sketchy, but it will do the trick and it will work. Okay, so all 4 are soldered on. Those are the 4, probably the 100K or the 20K, I'm not sure. But I kept these separate just so I wouldn't mix them up. So these are the other 2, or other 4 rather. Let's just cut off the little tape. We're going to do the opposite. We're going to thread these in the other side. I mean, this is so sketchy. If I had paid attention to the building materials, then I would have known I had to order some 120K resistors. It's not a value I've ever needed before. There we have these 2 resistors up against each other. I'll just have to put these leads together and we will solder those on. Well, I'm definitely not proud of what I did here with these resistors, but this does get the job done, and maybe this is incentive to print that 3D case to hide the ugliness that I have done here. Let me just bring in the multimeter here, and we'll just double check that these are indeed 120K now. 119, 120.00. Well, that's quite accurate. 119.91, 119.90. Double check this one. 119. Okay, so everything is about 119.9 or 120, so looking quite good. So the rest of this is self-explanatory. We got the connectors, and you see there's even a notch in the silk screen which matches the notch on here. So it's perfect, very easy. You just line this up and push it on. All right, those are all connected up. So what's left on here? We have 3 capacitors, and actually there are 3 test points that Sven put on here. I think test point is 5 volts, there's a ground one, and another 5 volt one over here. I won't put those on for now, I don't think I need those. Alright, I think the camera cut off when I was soldering on the capacitors. Now the camera did not crash. It just has a file size limit for video recording, which my new camera doesn't have, so it can record indefinitely until the card fills up. So now what's left is to install these 2 ICs. These are 4066s. And yes, I got these from China, so I think they work. Do I know if these work? I can't remember if I was able to test these. I don't know if my IC tester, does the Mini Pro test these? I don't remember. Anyways, we'll install these. Hopefully they work. Just bend the pins. Oh, I overbent them a little bit there. So there we are. I think the user port is done. And then the cassette port, that should be done. And the keyboard connector thingy inside the computer, that is done. What I need to do is open up this connector to put 2 jumpers in here. And then we have the cables to make. Well, it's time to make the cable, and that weird noise you're hearing is actually my water heater, which is just sitting to my left. The gas is on heating up water, I guess. Anyways, that'll end shortly, so you won't have to hear this weird noise too much longer. So these boards are all done, and I just need to make the cables. So I have quite the assortment of ribbon cable. This is all the standard spacing stuff that you find on a floppy or IDE cable. So if you're making one of these for yourself and you don't have a roll of this cable like I do, then you can either buy some from AliExpress or just take old IDE cables and peel them apart. Now I'm going to use this rainbow cable because I just love how this looks. This is so 70s to me, retro feeling. But I will just peel off the amount of conductors that I need for the length that I need, and then we'll crimp these connectors onto the ribbon cable. So we need to figure out how long to make the cables. The user port is on this side of the 64. So there's the user port. The cassette port on the 64 is right there, right next to it. So a little short cable is all I technically need with that. And then of course the furthest away are going to be these two ports here for the joystick controller ports. Now if I take a spool of my cable here, I want to make sure there's a little extra length so it's not tight. So I need at least this much. So let's get a marker, and I'm just going to draw a line on the cable right there just to give me an idea of how long that is. But before I cut any of this cable, I want to see how long the runs are on a Commodore 128, specifically the 128D. The 128D, it's like a beast, this thing. It's so big. All right, user port is in the same position as on the 64. So I'll connect that up right there. And the two controller ports are right there on the side. Let's see if this is going to be long enough to reach. Absolutely it will. Something that's odd on the 128D though is while the controller ports are here and there's the keyboard port, the cassette port on the D is all the way up in the front there. So I'm gonna really need a long cable. So there are two lengths of cables. This is the one for the cassette, so I'm gonna move that over to the side so I don't confuse them. Basically, of this one, we want to count to 10 because there are 10 conductors on it and peel this apart. Even though this is a DB9, we're going to use a 10 conductor ribbon cable because that's what these IDCs come in. It's 2x5. So we're going to split it apart, and I made a little mistake and I split the black wire a little bit, but it's not the end of the world. And you just peel it apart. So before we crimp the connectors onto the cables, we need to identify what is pin 1. And nicely, the IDC connectors here have a pin 1 marked with a little arrow. So there it is there as well. And it's also on this part, which is what we're going to be crimping. See the little arrow right there? That's the 1 pin. Now, fortunately on these DB9s, there's nothing marked. Sven provided a diagram that shows you exactly where pin 1 is. And I don't know where it is exactly, but the pin 1 on the cable is lined up with that blue line. So for the cassette cable, it's going to be exactly the same. He's very clear with the way these go on. So you just have to make sure that the colors of the ribbon cable match and that the orientation of these two connectors is exactly the same on both ends and it matches the picture. All right, now I use a vise like this. You could use a tabletop type that is portable, but this one is actually attached to my bench here, this other workbench. And there's a special tool that's designed for crimping these things. You know, I don't have that tool, and there's a different die for each one of these sized connectors, and you know, that could get expensive. If you make a lot of cables, it's definitely worth it. All right, let's start with the cassette one. So you take the IDC connector and you have to pop the little cover off if it's on there. And if you have an existing cable you can carefully prise the little prongs out and pull it apart. And actually, you know, to make a new cable, you can peel these off. But these were brand new ones from China. So if you notice, there's little prongs there. They're little V's. And the wires line up perfectly with that. So you just sort of line that up. And then you put the cap over it. This little cap here, you slide that over that. And we're going to put it all in the vise and clamp it down. And that will basically push the conductors onto the little prongs. Sometimes I find it easier actually to slide the little thingy over partially. And then you feed the wire through. And it's just in the vise there. If I move this, get a little light. And then as I close the vise, it's actually pushing the wires onto those little V's and making connection. Now, if I turn this too much, it will crush the connector. So you don't want to do that. Listen very carefully and it will click in. All right, I didn't hear a click, but I'm just going to take it out, give a little inspection. Well, I think that's good enough. I think it's on there. With the 9-pin connectors I bought, these only have 9 spaces in there, so one of the wires of the 10 conductors, see this purple one is off to the side. Now I'm holding this and I'm going to crimp this down in the jack, a vise I mean. Luckily I have multiple of these connectors, so if I screw these up, I can just try again. So I recommend you don't buy the exact amount you need, buy some extras. So I recommend after you crimp these that you check for continuity. So to hook everything up, we just connect it up to the various boards. He made the connectors so you can't screw it up. And we have the keyboard connector. Now I did tone these all out, so essentially put pin 1 here, and on the bottom of the board where they connected, pin 1. I had some issues because it seems that the wire I bought, this ribbon cable, isn't quite the right size. It's slightly too small. So I had to split the wires slightly, just so when it went into there it would align correctly, and didn't always make good contact. Well, since this harness is designed to be used on a 64 that's already pretty much working, you're just testing all the I/O ports, but you should have a blue screen. So make sure you have all your cables hooked up correctly, that you get, there we go, basic. So I know that's working. And I'm going to use this diagnostic cartridge I have. This has dead test and the regular test, the one that matches the harness. On here, you just have to change the dip switches. I use this a lot during my 64 troubleshooting series. Plug that in, make sure that it works. Good, we got the diagnostics running. Why don't we connect this up? So this goes on the user port, and these are really tight connections. That goes there. Here is the cassette cable with the very long ribbon cable. There we go, let's connect this up. And then we have these two controllers. It says on the board, controller 1, so this is controller 1. Controller port 1. And this one is controller port 2. Wow, you know what? I've made these cables pretty tight lengthwise. Thought I had enough length, but let's take this off because we are going to need to put the loop back on the keyboard. Well, there's the keyboard connector right next to the ZIF socket, and here is the loop back connector. Now it's going to be a little tight because of the ZIF socket, but it shouldn't be an issue. Just push that on there. The LED is right there, but it's not touching the pins underneath. Plug in the video cable again, and here we go. Hopefully no smoke comes out. Well, right off the bat, no ICs show as bad. Oh, I forgot to make the IEC connector, and I didn't even plug that in. Alright, well, serial port is bad because I forgot to make the IEC loopback, and then it's showing one of these is bad. But I wonder if that's related to serial. So let me create that connector, and we'll run this again. Okay, so this is the IEC connector that I'm going to open up and solder inside. We need to push this down, and then you slide this cover off, and then before we put it back on, we're going to bend that back. So, good excuse to use helping hands. I have the connector in there, and I'm going to use some of this off-cut wire. Let's try and get this hot. Alright, and the other side, if you get these pins too hot, it will melt, and they will slide around. And kind of, you can push them out of alignment, push them out of the connector entirely. Alright, so now we're going to do the bottom 2 pins. It's pretty crappy. I'm just going to lie that there. See if I can get this. Okay, and I'm just going to trim off this excess. So there we are. The pins are connected. The connector's back together. Let's test the continuity. Top 2 pins. Yep, and these 2 pins. Alright, time to test this again. So we have the serial loop back adapter. Let's plug this in. There we go. Everything else is connected, and let's power this on. Trying to fix the moire by making the camera slightly out of focus. So far so good. Let's see how this goes. Oh yes, look at that. Everything is okay now. Just the interrupt test, that's okay. So no chips report bad. The SID is testing. Now why don't I unplug one of the control port, pull the control port cable off, see what it does. Oh, interesting. Control port bad, but down here, which was blank, it popped up 4066 at U28 bad, which is the chip right here. Obviously that has to do with the joystick ports, and I bet you because I unplugged one cable, it thinks that chip is bad as opposed to the 6526 that controls the joystick ports. Well, that's going to be it for this video. A huge thanks to Sven for sending me those PCBs so I could finally build my own diagnostic harness. I've been wanting one of those for a long time because, as you guys know, I troubleshoot and test lots of Commodore 64s on my channel, and it's good to know that they're fully working without me having to plug in a bunch of joysticks and peripherals and test everything. I did spend some time plugging that harness into my own Commodore 64s, looking for one of them that maybe had a hidden fault that I didn't notice, but unfortunately I didn't find anything. Now, we all know that Commodore 64s break a lot though, so I'll probably have a fault in the future on one of those machines, which will lead to another troubleshooting video. If you like this video, I'd appreciate a thumbs up. If you didn't, you know what to do, thumbs down. Subscribe for more videos, and hit that notification bell if you'd like to be notified when I upload new videos. Put your comments and suggestions in the comment section below, and thank you very much for watching. Goodbye.